Hello, everyone. Good evening, and welcome to day one of the data science bootcamp from LogTech. My name is Dominic Kishatingunimye, but you can call me Data Kish. So I'll be your instructor and anchor for the data science bootcamp. Thank you. So, yeah, I like the turnout so far. I can see over 100 people have shown up, and that's beautiful. So I'm already very pumped for this. So let's dive right in. I'll be sharing my screen in a moment. And okay, so thank you. So just bef- like I said, today we'll be introducing data science and introducing the thought process of a data scientist, thinking like a data scientist. Once again, I'm Dominic Kishatingunimye often, but you can simply call me Data Kish. So on the chat, I'd like for you guys to give me a thumbs up if you can hear me and if you're psyched and pumped for the rest of the session today. Give me your favorite emojis, everybody. I beg, please. Thank you. Thank you. I can see your reactions. Thank you. Thank you. Thank you. So, moving on. What is data science? What is data science? This is like one of the one of the core questions to ask whenever you hear about the field. So rather than taking to heart or cramming bulky definitions, if you're to remember anything about data science, at its heart, data science is about generating insights. In simple terms, it's about making smarter decisions. So it's about using information to make smarter decisions. Data science is not just about computer coding. Obviously, there is computer coding, but that's not just the core of data science. But it's about asking the right questions, finding meaningful answers hidden in data to solve real world problems. So you could think of it as transforming raw information into actionable wisdom. I'll give you case scenario. Case scenarios involve from before in the olden days, if I'm to move into a business, I would likely want to sort the expertise of someone else who has been in the business before, or they would even sort oracles of the gods to tell them about what the gods think about what they intend to do as businessmen. But fast forward to now where we have the ability to store information. It's now been found over time through this field of data science that you could use information that has been stored to generate insight, to be able to now predict the future if possible. That's what has led to the advent of the current AI flux we see. So at the core, data science is making use of information that has been stored to generate insight, to making smarter decisions. So why does it really matter? Like I said earlier, for what's very important to us in this generation, for business growth, you could use data science to optimize your sale. When you have data stored about your sale, you could use that data to tell more, to see more, to do more from the data that has been stored, to predict your market trends, and to also enhance your customer experience. In healthcare, data science has been used to improve patient diagnosis. Ordinarily, there's no core science that would not even end with you having to carry out a project that would require you to collect data, analyze said data, and give your findings and discuss those findings and give recommendations from that findings. So it's infused in, if not every field of science. So in healthcare innovations, we cannot exclude the use of data science. We can now use data science to even personalize treatments for patients, to tell that, oh, a certain treatment plan best fits a patient category. We can now develop new medicines from data science. In the public sector, data science has been used to boost urban planning. With the use of, with or without the use of artificial intelligence, data science, the use of data has helped redevelop, re-strategize, redesign, and implement public safety, and even making it sure that government services are more efficient. Okay. So now moving on to the next part of the discussion are the roles that lie in data science as a field. There's a lot of roles in data science, and I gathered this material from three different online sites for hiring sites, and the eight major data science roles that exist worldwide. And this was to display how each of these different roles earn by their yearly income on these different sites. And we could see here that a data scientist on the world stage earns nothing less than $70,000. Although it's not very easy to get there, but it is with consistency. So a junior data analyst, which is a role, these are several roles in data science, by the way. So the roles that exist in data science are from data analyst to being a data scientist to being a data engineer to machine learning engineer, and then even being um, a director of data science. So being a junior data analyst, salary ranges from $60,000 to $75,000, sometimes from lower 49 to $100,000. You could do these conversions to naira, by the way, so you could see how this influences you. So a junior data analyst is someone who would enter the role of being in the position to clean the data sets provided by a company, make simple transformations, be involved in pulling out basic insights and reporting to whoever is the lead data analyst in a group of analysts or whoever is to report under. Whilst a data analyst, junior data analyst and data analyst can be employed in almost any field, in business related companies, in healthcare, in training institutes as such, like I'm doing right now, in construction companies, in broad scopes tech companies, in a whole spectrum of involvement. So a data analyst job ranges from being able to collect, pre-process the data, clean, manipulate the data, which are the things we will touch through the course of this program. Oh, and I'm hoping at this point in time, if you haven't liked or subscribed to our channel, you will do so now, please. Please remember to do so. Thank you. So, a data analyst, like I was saying, someone whose job would entail handling the data to the point of generating insights, like I keep stressing on. A senior data analyst is someone who has covered a wide variety of tools. On our D2, we'll talk about the different tools that a data scientist or analyst or whoever is in data science is exposed to. But just to give you a preview, you'd be exposed to basic tools like spreadsheet tools. I'm sure, hopefully, a number of us should have heard of Microsoft Excel. So that's a spreadsheet tool, a very common spreadsheet tool, where there's an alternative like Google Excel and Google Sheet, sorry. And that's one of the tools being used by a data analyst. And then there are visualization tools, which are tools used to display these insights that a data analyst will generate at the end of the day. So being a senior data analyst, you must have covered from these spreadsheet tools to these visualization tools to database language, the core database language, SQL, manipulating a database um, interface, as well as programming languages like Python, R, and Scala. So a senior data analyst is someone who has covered possibly about all these categories of tools and is able to use these tools in turning data into insights. Then a data scientist. The core difference between a data scientist and a data analyst is implementing these insights into the production of a software. So when a data analyst generates an insight, he finds out that, oh, there's a relationship between the kind of product certain customers would buy and the time of day they would visit or the area these customers are coming from. The data scientist moves from using that insight into developing probably a model that is now used to push maybe in an online market to push specific products to customers, to suggest it to these customers. I'm sure you've had product suggestions before whilst going through the internet, and you'll be wondering how this happened. How were these products suggested to you that seemed so accurate to match what you had in mind days before or what you've thought about before? So all of this work is what a data scientist does. He now makes use of these insights that have been found to produce programs that will carry out these functions, all to the point of producing programs that probably would be able to train artificial intelligence. I'm sure you've had situations where you had to click on capture, image capture, where you had to choose certain images before. So a data scientist is one who is involved in these processes where there are selections of images users are supposed to click on to train a certain AI that they are unaware of. Categories of users are made to see certain things or do certain things without having an idea of why this was displayed to them. As old as weather prediction, data scientists have been involved in this. They make use of weather data to create models that will predict the temperature, the amount of rainfall, humidity, and all of that from historic data. So a data scientist job ranges across different fields to the same way a data analyst does. But the core difference is a data scientist goes beyond finding insights to implementing these insights in the production of software products. That could even be used beyond software, could be used in robotics, could be used in real treatment, medical treatment products. So as we keep going, we will expose how all of this happens. And then a senior data analyst, as you see, the extra addition of the word senior would imply that he has a higher coverage of tools and years of experience under his belt. And then the business analyst is simply a data analyst in simple terms whose core function is in business analysis. So he has mastered the art of business management, analysis, business insights, all to the point of being able to make a company, a firm, whatever business enterprise grow from whichever data they can accrue. And then a data engineer, being an engineer, he's responsible for building structures. The structures a data engineer builds is such that would link the data collection frameworks. So I'm sure you'd go to buy something from a supermarket and you see whoever attends to you entering what your the purchases you've made. So a data engineer is involved in building these frameworks to collect data that would in turn be used by analysts and scientists to generate insights and products. So his core function is to make sure these frameworks, these pipelines as are usually called, are well structured all the way from collection to pre-processing to needed manipulations and then presenting the data in such a way that an analyst and scientist can make all use of. And then we move to these are more recent years. These roles, the last two roles, or this next role rather in particular, machine learning engineering, is more in existence in current years where there's now the advent of machine learning. So machine learning, as it's called, is being able to optimize the computer to learn, in simple terms, to carry out tasks that ordinary programming would not have allowed the computer to carry out. So I could teach my computer to know the right response to give to a text when I say hi, when ordinary programming would need me to give it specific responses to carry out. But with machine learning, it will have a wide variety of responses based on how much data it has been able to go through to teach it. So at the core, machine learning is where we now implement data science with the computer. There's one thing I haven't mentioned that I should mention now, is that at the core of data science is the use of statistics. So most, if not all of the insights to the product generated require the use of statistical models, statistical tests, basic statistical analytic measures. So we would all also mention that through the rest of the days of this bootcamp. And then being a director of data science, as it's implying, would be someone who's in the position to take lead or charge of the different roles or the different aspects of data science that exist. So he coordinates the activities of every other role enlisted right here. And obviously, his pay would have to be higher because he oversees, manages, and reports directly to whoever is the operations director of the company, or whoever he's needed to report to. So you can once more go through this and see how this excites you. Yeah. Okay. So data science versus data analysis versus AI. I thought it necessary to stress this so that at the end of today, there's a clear difference for us to go home with. So there's usually an intertwine with these different roles and concepts, but it's good you have just basic understanding of what differentiates them. They overlap nonetheless, but they have distinct focuses. So data analysis checks what happened and why it happened. While okay, I'm having a bit of an issue. So okay. So data analysis checks what happens and why it happens. It summarizes and interprets historical data. So if you've kept records in whatever area you find yourself, which is one of the things that data science would expose you to, proper documentation. So wherever you find yourself, if you intend to have more insight about whatever field you are in, you now start having a data oriented mindset that for me to be able to tell what has happened and why it has happened properly, I need to be able to collect data in that regard. So in data analysis, collecting the data in that regard is what your key focus is. All through the different aspects of data science, by the way, collecting data is very key. When in data analysis, your key focus is in trying to summarize this data that has been collected. I could decide to just collect, and we have been collecting data for a long while now. So in a school, you could decide to just keep records of your students' names, their basic demographics, their age, their height, or if that's needed, their gender, and all of that. You could go ahead as keeping more data. And at the end of the day, summarizing this data helps gives you insights in views you never even thought. You could now realize that, oh, we have more students from a particular demography. And with that simple insight, you would probably start seeing where there's need for finding out why. Why do we have students from this demographic? I'm using a school as a case study. Or you could find out in your business settings that I'm making money from, or more profit, sorry, from a particular product. Although I am selling more of another product, it now begs more question for you to find out why. And in finding out why, there's a lot more insight you will know that would help you make changes, decisions, and plans in your business. So that's where data analysis key focuses on summarizing data that has been stored and interpreting it. Where in data science, it moves ahead beyond just finding out what happened and why. You now start thinking about what will happen and what can I do ahead of what has happened and why it has happened. I will now start trying to predict future trends. It's in the advent of prediction that we now came up with models that could do things like weather predictions, like I had earlier mentioned. So you could now do um, prediction models to help predict strategic decisions for companies. You could do forecast analysis and be able to tell where a company should be at certain times. You could do business related analysis that are called pestle analysis. You could do a whole lot more. And then in artificial intelligence, where it's currently the hallmark of today's technology, we now apply data science in how can systems learn and adapt. So we now start creating intelligent machines that can mimic human cognitive functions, machines that can ultimately speak, understand your language, large language models, LLMs. We can do machines that can interpret pictures. We can do vision based models. We can do machines that can self drive. Those are reinforced learning AI models. Although with this bootcamp, we will not go that deep because it requires more time to learn such. But we will touch the core workflow of data science. Do not worry. So, while data analysis looks to the past, AI builds autonomous systems. Data science bridges the gaps between data to forecast and to guiding future actions. I know you're already feeling very pumped. So I'd like to see your reactions in the comment section, please. If it's been exciting so far, and if you've been following along with me as much as I'd like you to, please give me your reactions and also put down your questions if there are any. So if there's still ample time when I'm done with the presentation, I could handle your questions. Thank you. And I'm hoping that this time too, you must have liked and subscribed our channel. Thank you. Okay, so I'll go to the next slide. What are the common misconceptions about data science? So, the common misconceptions about data science is when somebody has like this a basic idea of data analysis, which is a part of data science, what they think of is that it's just about charts. But nah, that's not true. It is way more than charts. Of course, you would need charts because it's visualizations. It's a better way to describe to present the insights you've generated from your analysis. That's why there is the need for charts, but it moves way beyond visualization. So it involves deep analysis that even charts may not be able to display. Although that may not be at the scope of our boot camp, but we would still talk about it. So in data science, we go beyond, we use a lot of other statistical models way beyond charts. And then, of course, like you've now learned, data science is not just about machine learning. Even though that's a powerful tool and it's a huge part of data science, it's way beyond just that. So you do not always need machine learning for any scenario. Yes, you probably just need basic insights from your data. In your small business, in your middle scale business, your small to medium scale businesses, you just need to have insights about what your business has been, about the data you've generated, to know what decisions to take. So you do not always necessarily need machine learning, and that's not just all what data science is about. But if there's one thing you should remember about data science, it's the fact that it is about problem solving. At the core, it is about framing real world challenges into questions that data can answer. So if I have any question that I want to ask about any field of study, data science exists such that you could use existing data to answer those questions. So It is crucial for us to adopt a problem solving mindset when you're coming into data science, where data is the guide to uncovering solutions. Thank you. So, this is the data science workflow I've been mentioning. So, at the core of data science, I think this is one of the things when I first started tech. I think I dabbled into other stacks. I dabbled into a bit of web dev, and I had to learn from HTML, CSS, JavaScript, and I saw that there's a whole lot more for me to learn. I didn't get to the point of JavaScript, but when I touched along the same line, I was introduced to data, and I noticed how the data workflow is sort of just easy to recall. And what it requires you to do now is replicate across tools that you use. These tools are the things we would use in the ongoing classes. The tools that I have mentioned earlier, like spreadsheet tools, visualization tools, programming languages. These are like, and then there are other IDs and other integrated environments we would use, but in all of these, the workflow sort of looks alike. It's almost always similar, although there'll be slight differences where I would, other than just do maybe generate insights like in number five, you can see I will go beyond that. But the workflow follows the same pattern. And I'll talk about this data science workflow. So if at your core, you know this workflow, you recall this workflow, you could already call yourself a data science. What makes you a data science without be practice a data scientist rather will be practicing this workflow. So you could call yourself a data scientist if you can practice this workflow with just any tool. So all you would require is to upskill from tool to tool. So the first thing you should do in the data science workflow is understanding the problem. I think this is what is even being used in our scientific project report. So it's defining a problem. So when you define a problem, it helps you. When you define a problem, right? When you define a problem, it helps you tell what the challenge is and helps you picture what your goal is. In other terms, we would always say objectives too. So it helps you clearly define the objectives. And then from those objectives, you now start targeting what kind of data should I collect, would I collect in regard to these objectives. So the data science workflow always starts with first pointing out what the problem is. So let's give a case scenario. Okay, what a problem is it could just be a question, by the way. So I have a business I'm running, and I want to inculcate the data-oriented management for my business, which is the best way for your business to grow, by the way. So one problem I could tackle is asking about my profit, which is like what everybody wants to see in their business. How do I tell my profit? A lot of business people carry out their business blindly. They know they do make profits because there's a difference in the figures they have in their accounts, but they cannot tell deeply what's really profiting them per se. Maybe probably over experience before they accrue the knowledge of this. But that's not what it should be. The case should not be that something happens in your business. There are scenarios where people lost a lot. They tend to lose a lot too from their businesses before having to find out why or that they have lost or that something happened for them to lose. But with proper data management and keeping, you already know that, oh, this is a problem I need to tackle beforehand. So I will now start defining these problems that, oh, the first thing I have to do is have a business statement, a cash flow statement that shows clearly how money is coming into my business and how money is going out of my business. Well, pointing out clearly at the end of the day, at the end of the week, at the end of the month, or at periodic intervals, what the expense has been done on my business, the revenue, the profit. So these are problems you point out And then it helps you define the next stage of the data science workflow, how to collect data. What kind of data do I now need to collect for my business to answer these problems I have stated? So you will now need to, we would answer all this, by the way. So this is what will guide the 5 days of our boot camp from the remaining 4 days, of course. So the next thing you will do is when you collect this data, most times the data being collected cannot just automatically be used into generating insights. You cannot just go straight into analyzing this data because of the format to which the data was collected. So many times collected data would have inconsistency. Maybe because whoever collects this data did not restrict entry, to did not validate the entry. So maybe I have a sales girl or a sales boy and we're using an Excel spreadsheet to collect data for our business. Or we're using a register manually to write down data for our businesses. And one person is writing down the sales of maybe a product in bags. Another person is writing the sales of that product singly. Ordinarily, that's already an inconsistency in data collection or data keeping or bookkeeping or recording. So that's why cleaning data is one of the key workflows, key points of a data science workflow. It's actually one of the points that takes a lot of time or takes the most time in many scenarios. So you have to handle this data inconsistency. You have to handle situations where they are missing values, where this person did not write how many of these products were bought. They forgot to do that. You have to find a way to resolve that. We will talk about how to resolve such scenarios, as I said earlier on. So how to resolve errors you would see in data that has been collected is one of the skill every data scientist picks up. From an analyst, even to an engineer, to the data scientist, is something you should know at the back of your hand, how to resolve these scenarios. And then we now move on to analyzing and exploring the data we have cleaned. So we explore this data and analyze it. Exploratory data analysis, as EDA as it is called, is very beautiful. It now exposes you to patterns you probably would not have even thought of. So you now start analyzing to answer your business problems. So, oh, sorry about that. To answer your business problems, and then to discover patterns, relationships, and to also see the insights, initial insights that your explorations would give you. So from there, you can now generate insights, clear insights. I can now go ahead to generate insights that, oh wow, I made more profits at the third quarter of the year in my business, and that's owing to a particular product. Or I made more money or more profit, more sales at the later or the fourth quarter in December in particular. And then I'll find out why. And I found out that it was due to the sales of a particular product that was bought periodically. But I don't make as much money in September. And I'll start finding out I made losses in September. So I made more sales in this period, and oh, I found out, oh, I make more sales towards 8 p.m. in the evening for my businesses. So if I'm to need more hands for my business, that's the best time to put more hands. If I'm to buy more of a particular product, this is the best time to buy more of these products. By the way, business owners wait till a couple years when experiences exposes this to them. But with collecting data, you would see these insights in no due time. That's the difference. And you don't just see it as something that is speculative. It is now a clear fact to you that, oh, this was what led to this, and this is what has done this is what can be done. So you generate insights. That's where you make use of charts to picture, to present your insights. And then you move ahead to communicate these results. So let's say you're a data analyst in a company. This is one very key thing for you to learn to do, communicating the findings you have made from the analysis. And we would learn all through this workflow, by the way. So learning how to communicate the findings we have made, how to present our findings effectively to stakeholders, how to drive informed decision making. So we're going to have a bit of a break now. And in the next 1 minute. I'll return. Thank you. Welcome back, guys. Welcome back. So, if you're still with me, I would like to see your thumbs up in the comment section. I would like to see you type out data science to the world in the comment section, please, if you're still with me. And thank you, thank you, thank you, thank you, thank you, thank you. So, I have a question for you guys, please. So, before we move on to the next part of the slides, I would like for you guys to type out the first workflow, data science workflow, the first data science workflow that you recall we had learned. Okay, I'm waiting. So no comments yet. Oh, okay, okay. So the first workflow, thank you, good news, is understanding the problem. So at the core of data science, that's the first thing you should always try to do. Before you jump into analyzing your data, you should try to understand the problem. So if that's not there, you try to look at the data to see what questions I can ask. So any question you can ask is already a problem that can be answered. Thank you. Thank you. So if you can recall still, can you type out which of the data science rule you would like to practice how to perform or to work as. For those of you that are interested in going into data science, type out which of the data science role you would like to work as. So I'm waiting for your comments, please. So to remind you of the data science roles, we have junior data analyst, we have senior data analyst, we have data scientist, senior data scientist, we have business analyst, we have data engineer, and we have director of data science. Which of these do you think sound like something you would like to try out? Or if it is all of the roles you would like to have in touch on, there's nothing wrong with that. You would get to specialize eventually. So just comment on which of the roles stood out for you. Nice, nice. Wise verse. Nice. Okay. So thank you. So let's continue. Oh, and I'm hoping once more that you have liked and subscribed to our channel at this point. If you haven't, please go ahead to do so. Thank you. Thank you. So the next thing to talk about are the types of data. So what is data? Although I had not put a text here to define that, but data is any information that can or has been stored. So any information you can store or has been stored is simply data. The unit of data is called datum, the singular in English. So if I just write down your name, it is data. This video we're recording is data. If we have a conversation and I hold it in memory, that's still data. But data are of two broad types. Structured data, for a data scientist, by the way, they are of two broad types fundamentally: structured data and unstructured data. And in data science, we now start learning to use these different types of data. Where structured data, as you can see, is to organize data into fixed formats, where it is what is being used in databases or spreadsheets. So you make it easy to search and analyze the data when you have it as a structured data, like you can see here. So like this is a financial data example scenario being displayed here, where we have columns and rows to collect the data, where one column collects information about a particular field, about a particular thing. I could just collect people's names on one column. I could collect people's ages on the next column. I could collect, okay, in this case, financial case, I could collect dates on one column. I could collect the product that was bought on one column. I could collect the amount, the quantity. I could even decide to document my profit on another column. And then each row would represent an entry, a distinct entry of what that data is about. If it's in the case of this business data, this financial data, each row would be a particular item sold. So if I sold shoes, I would enter every row. The row for the shoe would have the date the shoe was sold, the quantity, the amount, like I've mentioned, and the profit if possible. And then the next row will be about another item. So I'm sure we've been collecting data. We've been recording things in structured formats for a long while now. And that's one way to keep data in a structured sense. And that's the best way to keep data that will make it easier to analyze. But there are some data we cannot necessarily structure. So these ones are always in this format, unstructured data. We cannot structure things like images in spreadsheets. We cannot put them in tables, in columns and rows. We cannot have emails and text documents in columns and rows per se. We cannot have social media posts in columns and rows. But these are still information that has been stored and we can make use of. I'm very sure you've seen ads pop up on your timeline, on your FYP, without explanations. And these are a result of several posts you've made or commented on. And this was the handiwork of a data scientist, by the way. So this was still the data he made use of in generating these models that would pop up ads for people, know who to present said ads to. And these are unstructured data. And as a data scientist, you'll be made to work with both structured data and unstructured data. So you should look out doing that. So data structures. So for structured data, which would be where our um, bootcamp would depend on, we'll make use of more of structured data because there'll be no time for us to explain the tenets of analyzing, manipulating unstructured data. But these 5 days will go in depth on using structured data to come up with insight. So most data you work with is always in structured formats, like I had said earlier. So structured format is tabular format. That's why as a data scientist, it is very important. It is very important to know how to use spreadsheet tools like Excel, Microsoft Excel, like Google Sheets. There are other spreadsheet tools or integrated environments like SPSS. There is um, there is Zoho. There's a whole lot. But the beautiful thing about data science is that once you know your workflow, you know how to use one tool. It's easy for you to pick up another tool and upskill and just learn to use it because you already know you have the intention of what you want to do. So most data you work with is organized, like I have said. So, like I said earlier, the rows represent a unique observation or a record. Like in this case, the row represents a customer transaction, and then the column represents specific attributes or characteristics. Where this first column for this data you see here is maybe customer ID, where we gave 101 for customer whose name is Alice Smith, who bought laptop at a specific date and at a specific price. So each column holds a particular attribute, while each row is for a unique observation or a unique record. And then in data science, we many times refer to the columns as the variables because the entries vary. So if you notice this first column where we enter the customer ID, it is 101 for the first entry, 102. You're noticing it is different. Because it is different, this column is called a variable. For this name, the names are different. So name is a variable. The items being bought, item is a variable. So individual data points within the columns are called variables because they would vary across entries. So over time, you would learn to now analyze in regards to variables, and this becomes more clear during your use of statistics and in your generation of insights. Yes, so thank you. For the next section, we'll talk about problem definition. So it's very key as a data scientist, stroke analyst, stroke wherever you are to be able to define the problem properly, to be able to frame your questions properly. And through the course of this bootcamp, we would also flex muscles around that, develop muscles around that if we have not developed those muscles, and get to explore a whole lot about knowing how to define our problems and frame questions. So I'll be hoping to see you tomorrow, by the way, because this would be one of the things we will talk about tomorrow, defining business problems. So the crucial first step, tomorrow we'll go in depth into using these tools. You make use of Microsoft Excel. So beforehand, if you haven't gotten Microsoft Office package on your laptops, I'm hoping you join with a computer, desktop, a laptop, any computer at your disposal. So you can follow along and practice, stroke, ask questions when needed. So the crucial first step, like I had said earlier, is turning a vague business challenge into precise answerable data questions. So you should be able to tell what your business problem is. So maybe my business problem is that my customers are leaving too much. In business terms, our customer churn rate is too high. Too many customers are leaving our business. So it's leading to a loss in revenue. That's a problem. So we now move next to what's the data question? How do we relate this to data? can we predict which customers are likely to leave our business? If we can tell which customers are likely to leave our business, that's one step at already solving that problem. We now know how to address these customers in particular. So you don't have to wait for experience to teach you. You can use existing data in your businesses to answer these questions. And then one very important thing that data scientists, analysts, and like I said, the different respects work on all alike are knowing how to tell what KPIs are, key performance indicators. So in this case, for this problem that I have highlighted, it is like the accuracy of our churn prediction model. Because our intention will now be to create a model that will help us predict what kind of customers leave or churn, what kind of customers um, get to not return to make business transactions with us. So you now know how to build your KPI, how to make the accuracy of that KPI very high, and ultimately reduce your churn rate. Because at the end of the day, you want to make money in your business. So this will now help you reduce your churn rate. So at the core, framing the right question is very vital for ensuring your data efforts lead to measurable business impact. So your journey begins here, everyone. Always remember this core principle. Now, data science is starts with understanding problem and not coding. So by focusing on the problem first, you ensure your data insights are always relevant and impactful. So in our very next session, we'll dive into the exciting world of data collection, how we'll explore data, having a case scenario project. So when you come to the session tomorrow, we'll have projects we would handle. We'll pick a business project that will carry through the rest of the course. So I'll very much like to see you tomorrow and like you to be involved in the entire process. Thank you very much. So at this juncture, I'd like for you to put out your emojis to show me your excitement for all that you have learned so far. Please do so. Please. Thank you. And I also like you to leave your questions, if any, in the comment section, since we still have a little time to address your questions. Okay. So thank you very much for coming on this session. And I hope you have liked and subscribed. Thank you. Thank you. Thank you very much. I would love to see you tomorrow. Good night. Good night.